Hello all nighters, this is Gordon Sathwik. Today I am going to discuss Introduction to FLAT. FLAT stands for Formal Language and Automata Theory. In FLAT, let us start with Finite Automata Model. This is the most basic model in this FLAT subject. This is used to construct regular languages. Only the regular languages can be implemented using this Finite Automata model. This is the basic structure of this Finite Automata model. It consists of an input tape, a read head, and a finite control. In input tape, we'll be having an input string which will be accessed by this finite control using this read head. This read head can only access the number, it cannot change the string value. And two more basic notations are alphabets are represented by sigma and strings in flat are represented by W. Now, in this finite automata model, if there is a transition, this read head will move to the next block. If there is no transition, it will be in the halted state. In this particular model, this read head only moves from left to right. The backward direction is not possible. And now let us consider a small finite automata, most simplest one, to understand what is a transition and what are the states. This is a basic finite automata. If you consider this, the one in the circles are called as states. Here the states available are off and on, and the alphabets are 1 and 0. And this arrow represents the initial state. To the initial state, we'll draw an arrow like this. And if we are in off state, on transition with 1, it will go to on, and on state with transition with 0, it will go to off. Off and on are the states here. These are the input symbols. Now coming to the applications part. The first one is text parsing. In text parsing, consider an adventure video game. It takes a series of inputs and simplifies it to the language in which a game can understand. And next one is traffic lights. This can be a clear analogy as we have seen in the previous example. There are three states, red, yellow and green, and upon a transition, red changes to yellow, yellow changes to green, and in the loop again the green changes to red and red goes on. And the next one is regular expression, which is used in compiler designs, and this is natural language processing. And coming to this one, speech recognition, it is used in our day-to-day assistants like Google Assistant, Siri, etc. Now we are going to see some standard notations used in the flat. The first one is star. Star basically means 0 or more occurrences. Next one is plus. Plus is similar to star, but it has one occurrence or more occurrences. One or more. Next, there are phi and epsilon, which we use the most. Phi means it represents null, whereas epsilon represents a zero length string. There is a string, but of zero length. Zero length string. Now, let us take the examples and understand what are star and plus in more detail. Now, consider an example of alphabets. As I said before, it is represented using sigma. Consider this as A. Now, simply we represent this notation as sigma star. What we have learned before, sigma star is nothing but 0 or more occurrences. 0 occurrence of A means there is no occurrence. That is simply epsilon. Next, one occurrence of A. Next, two occurrences of A, and it continues so on. And similarly, sigma plus. Here we start from one occurrence. That means zero occurrence of A doesn't include. So we start from one occurrence, that is A followed by double A and so on. We can simply establish a relation between the sigma star and sigma plus, that is sigma star is equals to sigma plus union epsilon. See, the only difference between sigma star and sigma plus is this epsilon. When we add this epsilon to this whole set of sigma plus, we get the sigma star. So this is the simply the relation. So that's the basic introduction of flat. In the next lecture, we will be dealing about finite automata types, that is DFA and NFA. Thank you.